everyone, and thank you for watching. My name is Peter Wolff and welcome today. We're back in the roastery today, and we thought we'd spend the time doing a walkthrough and a walk around a P5, a Probatone P5 roaster. We have focused in the past, I guess, on individual components, but today it's about linking everything together and understanding where each bit fits in the scheme of the greater roaster. So what we might do is start around the back and look at where the gas comes into the roaster at that point. So we'll head around there now. So we're at the back of the roaster now, and I guess the main thing, we have our gas line, which is right here. And this is coming in off the street, so this is, we're running off natural gas here. Our supply pressure, or metered supply as we call it, that comes in off the street is 35 kPa. So we have an isolator that should be in line here before the appliance, and this allows us to turn the gas off safely in the event of an emergency, and also if we're doing any sort of repairs or maintenance on the roaster. So we isolate right here. From that, we engage the gas. It should then come through to our first main regulator that we have here, and the purpose of the first main regulator is that it's going to reduce the amount of pressure that comes from 35 kPa down to about 20 kPa right here, so it reduces that pressure down again. And the main reason why we're trying to ramp down the pressure going into the roaster is that we don't want to over pressurize or put too much pressure against the valve, the gas valve that's inside it, because you can damage the valve because there's too much pressure sitting behind the solenoid there. So we want to reduce that. This is a requirement here within Australia that this is also a self-venting valve. It's called an OPSO is what we call it. And so from that we pass through the OPSO and we have another T-piece, and then obviously that goes into our appliance, and we have one more sort of isolated valve on the appliance as well. And that's just located over here. What we'll now do is just go inside the roaster and have a little bit of a look at where the gas picks up from inside the roaster. Okay, so we're now on we've opened up the side of our roaster here, and right where my hand is here, this is on the inward side of basically where the gas comes into the roaster. It passes through another gas filter, which is what we have right here, and this actually, funnily enough, filters out any particular particulate that may be in the gas, so it literally is a filter. And then we have a T-piece which runs right here. This upward stem goes up to the gas pressure valve that gives you an analog reading. Coming off this T-piece on the silver braided hose, it does come around and then sort of connects into the burner. And then into the bottom of that burner we have our first gas pressure switch, and this is this pressure switch that regulates the amount of pressure that comes into the valve. And what sits next to that is a solenoid valve, and establishing that we have the right amount of pressure coming into the roaster, it will open the valve, the solenoid valve, to allow the gas in, or if there is a case of overpressure or under pressure, it will close the valve off for a safety reason as well. That gas pressure switch then comes up into the multi-block, which is here, and the multi-block really is that really key piece of componentry that not only controls how much air and gas comes together or gets combined, the speed of which that does, so it literally controls the power of the roaster, but also I guess the richness, so particularly in terms of a premix burner, how lean do you want to run the fuel air mixture on that. As it passes up through the gas multi-block, it comes up here into the fan, where this is obviously blending the air in together. You will see that what does come off here is another air filter, and we have these fitted on the roasters because we want to be filtering out any of the dust and dirt that may make its way into this fan blade that's here. It comes through here where it's going to be combusted and lit into the firing unit, but below that we have another gas combustion switch here. So we have not only a pressure switch for the gas, but we also have a combustion pressure switch here on the front side, and this is also regulating the amount of gas, fuel air gas mixture coming into the burner head. Now we do have two ignition electrodes here, or electrodes that come off the bottom here. Now these electrodes we have spoken about earlier, but the main thing with the electrodes is that they're both identical, but where they're controlled is by the ignition controller, which is down here. So one will create the spark, and as you can see, the sparker is this one here, and so just below the ignition switch we have basically our sort of spark pack, or our ignition lighter, and this is really where the energy is created, and this is what will create the spark. And so from that connection, basically, so this is basically our igniter, and so this one here is our flame sensor. So this needs to detect that we're actually holding a flame in the roaster. That's all controlled here by our ignition controller. The ignition controller is basically a programmable unit that basically has all of the parameters in it in terms of stabilization rates, purge time calculations, and various other sort of requirements that may be needed to have your roaster certified within your sort of state and territory. Below that here we have is our cooling fan for our cooling exhaust, which is the separate sort of independent system, and then that sort of really takes care of what's inside the roaster here. So we're just coming around this side, and I've opened up the switchboard, and we're looking more, I guess, on the electrical side and the electronic side of the roaster. This is certainly an area that you would not normally kind of be delving into unless you are a qualified electrician. I have turned all the gas and the electricity off on the roaster, but we'll come down and just walk you through some of the key items that you may come in contact with or need to be familiar with on your day-to-day operations. So a couple of things that we have here is one of the things for most of the modern roasters in particular that have some form of roast control system or the premix burners is a PLC. So we have a little small Siemens PLC unit right here. Next to that is our transformer. Some of the components here on the roaster are 24 volts, so we need to look at reducing that down from 240 volts down to 24 volt. So that's what that piece is there. There are some additional things here that you may be looking at that seem different to your roaster. We have some additional things added to the roasters, relays, for example, for additional wiring that will be required as we have this wired to an afterburner, so we need to be creating interlocks between the afterburner and the coffee roaster. The main sort of set of switches that I guess that I want you to have a look at is this little row that sort of lives along here, and these are our thermal protection switches that sit below the contactors. So that's a contactor above it, but below it this is a thermal protection switch. Each of those little yellow dials have a series of numbers on it, and this is basically managing the electrical load to each of the motors, so whether that's for the drum, whether that's for the cooling exhaust, whether that's for the roasting exhaust. So we have for the agitator as well that sits above that on the cooling tray. So there are our 4 motors on this particular roaster. So this has a thermal protection switch on it, so should the motor go into duress or jam, or should it overheat, this is where the safety switch will trip. Typically you do find on installation that this is one of the areas where it requires some sort of, I guess, teething and adjustments, because it is sort of dependent on sort of the ambient conditions of the day. I typically tend to find, and it's just an observation, I'd be interested on everyone else's thoughts, but I typically find when we're having roasters that are built through a northern winter, we do tend to find that those roasters, I'm not sure if it's the adjustment that's chosen at that particular time, but we always do tend to find here in the warmer Australian environments, we just need to adjust them slightly. We do tend to find that those motors trip a little bit earlier because of the temperature. Below that we have we have an Ethernet Modbus here connection, which will relays back here and to the external plug to the Cat6 cable that goes to our computer, and that's obviously the communication hub that's talking to the PLC and the roaster and taking all of that information in to drive the roaster through the Pilot Roaster Control software. We do have a variety of cards and switches. We then have our standard circuit breakers that you can see along here, another range of contactors as well, and relays that are specific again to the installation for gas safety here in Australia. So it's certainly a side to the roaster that you need to know. There are a couple of particular cards that are fairly sort of important that need to be sort of looked at, and particularly I guess looking at the one where the thermocouple comes into, so that's generally a 1 or a 2 port card that goes in, or temperature control card. That's this one just here. They need to be looked at. You typically will see that you have a combination of green and red lights that run along these when they're lit up. All green is obviously good, all red generally bad, or if we have a combination of red and green, it can also indicate a fault as well. It is dependent on the brand that's chosen. But that's just a quick look inside the electrical side of the roaster. We do have the e-stop on the outside. Some roasters do have a counter here on the outside which gives you the number of operating hours. So this particular roaster that we're looking at here is coming up to 5,600 hours, which is a fairly a good sort of hours for a roaster of this age, which is good. There you go. We come up to the top here. And then, you know, we're sort of at I guess more of the operator's side of the roaster, where we have hard on, off and ignition key. On this particular roaster, this is our gas adjustment. This will be air, drum and cooling agitation, and then our 2 switches here, which will both be temperature and time. And then as we move to the front of the roaster, then we've obviously got the general operating areas being the trier. We have the front bearing, we have the door, sight glass, green bean chute that discharges the green coffee into the roaster, and then we have obviously the in-feed hopper. So there you go. That's a walk around a Probat roaster and the general bits and pieces. I hope you enjoyed.